The Process of Ocean Acidification and Its Influences and Implications, presented by Andy McCarthy. Over 200 years ago, the onset of the Industrial Revolution changed the scape of US and European economics, vastly improving quality of life and standard of living through mass production of goods. Inversely to economics, automation and machine processing, namely the burning of coal for power, has taken its toll on the environment. As society has enjoyed the benefits of easily attained goods, pollutants have been pouring into the atmosphere and waterways, and we are now seeing the negative effects of a deteriorating environment accumulate at a rapid pace. One of the largest potential threats to our environment, and therefore ourselves, is ocean acidification. Not often considered, since it is out of sight and out of mind for many, are the physical properties of the ocean that marine life depends on. These variables include pH, salinity, and temperature, and are being altered at an alarming rate by human influence, largely in the form of greenhouse gas emissions. These gases include carbon dioxide, methane, nitrous oxide, and fluorinated gases, and are found to be significant drivers of climate change. As technology and globalization of economics rapidly increase, so has production of dangerous pollutants. Worldwide, emissions of atmospheric greenhouse gases have increased by 35% from 1990 to 2010. Carbon dioxide accounts for the majority of these emissions and interacts directly with the ocean's surface while in the atmosphere. Our vast oceans absorb about 30% of the carbon dioxide that is released into the atmosphere. Atmospheric carbon dioxide that mixes with the ocean surface starts a chemical reaction that results in increased acidity. The free carbon dioxide molecules combine with water to create carbonic acid. This reaction results in excess hydrogen ions in the water, which decrease the pH, increasing acidity. The reaction also consumes available carbonate ions, which are crucial for marine life to calcify shells for protection. As concentrations of atmospheric carbon dioxide have risen over the past 200 years, the pH of surface ocean waters has fallen by 0.1 pH units. While 0.1 units is not an alarming figure at first glance, the pH scale is logarithmic, which means a 0.1 unit decrease equates to about a 30% increase in acidity. This rate of change over the past 200 years is approximately 100 times faster than anything the ocean and marine life have experienced in tens of millions of years. This change is already enough for us to witness the impacts it is having on marine life, and the scenario will only get worse before it gets better. Atmospheric to oceanic carbon transfer isn't the only pathway through which the ocean is becoming polluted. Coastal acidification is a current phenomenon where freshwater river inputs carry excess nutrient runoff, usually in forms of nitrogen and organic carbon, into our coastal waters. Shellfish predominantly inhabit coastal regions, and in addition to projected stress caused by global trends in ocean acidification, some coastal ecosystems receive pollutants from freshwater inputs, exacerbating the problem. Coastal acidification poses a particular threat to society as humans rely on the abundance of marine life that inhabits coastal waters. The issue at hand with ocean acidification, as well as other phenomena related to climate change, is the rate at which change is occurring. Large-scale mass production that defined the Industrial Revolution was relatively abrupt change that has drastically changed the environmental landscape already. Nature is resilient and adaptive, but natural environmental changes tend to occur at a much slower rate. Any naturally occurring changes as abrupt as the changes that humans have made to the environment are generally considered catastrophes, such as volcanic eruptions that alter the atmosphere. Similarly, the rate at which fossil fuels have been burned by humans is well on its way to having catastrophic effects on the environments around the world. Fossil fuels have proven themselves to be an effective way for humans to generate power for our ever-increasing complex society. The extraction and combustion of fossil fuels, which include petroleum, coal, and natural gas, account for 69% of greenhouse gas emissions from human activity and provide 86% of the world's total energy production. The burning of fossil fuels is so embedded within our global culture and economy that ceasing to do so would bring the global economy to a grinding halt. This poses a particular problem given the relatively newfound knowledge of the severity and implications of climate change. Our society demands to be slowly weaned off of fossil fuels while the effects of their pollutants compound within our atmosphere and waterways. Renewable energy sources such as solar and wind and energy require mass investment so that humans can continue to power the society we have created while mitigating as much environmental damage as possible. Another compounding issue exacerbating the effects of atmospheric pollutants that lead to ocean acidification is deforestation. Plants are highly effective natural carbon sinks, sequestering carbon dioxide pulled from the atmosphere within their biomass. Some parts of the world, namely the Brazilian Amazon, are subject to rampant deforestation, sometimes even illegally. Much of the dense South American rainforests, as well as areas within Africa and Indonesia, are deforested unsustainably, effectively reducing Earth's natural capacity to mitigate the greenhouse gases humans are pumping into the atmosphere. There have been international agreements such as the Kyoto Protocol, which raise concern over factors of climate change and decidedly promote afforestation, instating incentives for countries to properly manage forested areas and even cultivate new forests with the intent of environmental benefit. Aside from reducing greenhouse gas emissions, an effective mitigation technique would be to increase plant biomass, which would aid in pulling carbon dioxide from the atmosphere. Unsustainable deforestation is working directly against this mitigation technique and weakening our ability to fight the effects of climate change. As mentioned before, harmful algal blooms are an acute threat to coastal waters. The onset of these harmful algal blooms have been linked to eutrophication, or an excess of nutrients entering the water from sources of agricultural overfertilization and industrial pollutant runoff. The excess nutrients mix with coastal waters where the algae reside and cause their populations to explode in numbers. When these often massive algae blooms die off, they consume oxygen in the water and release carbon dioxide, furthering ocean acidification. Some of these algae species themselves are toxic and pose a triple threat to marine life through the toxins they release, as well as consuming water-bound oxygen and then releasing carbon dioxide. One of the greatest threats that ocean acidification poses is that to calcifying marine life, such as corals, oysters, scallops, mussels, starfish, urchins, and some plankton. The process of calcification that these animals use to grow their protective shells utilizes carbonate and combines it with calcium ions in the water to make calcium carbonate shells. Under acidic conditions, excess hydrogen ions in the water bind to carbonate, depleting the supply of carbonate building blocks for their shells. Not only does acidification reduce the number of shell-building molecules in the water, it also degrades existing calcium carbonate shells. In laboratory experiments, pteropods, which are shell-building plankton, were exposed to levels of acidity that are predicted to occur by the year 2100 and were found to have visible degradation of their protective shells within just 2 days. The inability for certain plankton species to defend themselves has severe implications on the marine food web, which rests upon their foundation. If calcareous plankton species were to rapidly die off, a devastating cascade would follow in their wake. Beyond plankton, many coral species among the reefs will struggle to grow their skeletons against an increasing erosive acidity. Fortunately, it's been found that some corals can cope better than others with acidification, and that increased food and nutrient supply can offset reductions in growth associated with acidification within coral reefs. Considering how crucial coral reefs are to marine ecosystems, the threat of acidification is still very real for these habitats. Even starfish calcify parts of their body for protection, along with spiny and stalwart sea urchins which nearly encase themselves as they move along the ocean floor. Sea urchins are affected in both their larval as well as adult stages. And while humans do not directly harvest or use these animals, they do provide key roles within benthic marine ecosystems. Shellfish alongside calcifying plankton have the least promising prognosis for survival. Laboratory studies estimate shellfish survival rates to decrease by a third in a year 2100 acidification scenario. Many shellfish have periods of rapid shell growth when they are larvae so that they may quickly begin to protect themselves out in the open ocean. When the larvae do not have the opportunity to form shells at this critical stage of life, they are left defenseless and undoubtedly will suffer increased mortality rates. Shells aside, it was found that higher levels of acidity also reduce larval shellfish ability to accumulate lipid reserves, severely limiting their growth rates in juvenile forms. Calcifying species aren't the only forms of marine life affected by ocean acidification. Studies have shown that certain fish, particularly pollock, have a difficult time detecting predators in acidic water. Clownfish also have a diminished chemosensory ability in acidic waters and were found to lose their ability to distinguish their usual beneficial habitats from poorer ones. Additionally, cobia fish exposed to more acidic waters end up growing larger otoliths, or these minute ear bones that affect hearing and balance, making it more difficult for these fish to detect predators and even properly navigate. Reduced chemosensory perception and dulled senses greatly increase predation risks for fish species, and it is likely that there are many more unstudied cases like these that are similar. Alternatively, there are some forms of life that may benefit from a more acidic environment. Some seagrasses, diatoms, and other forms of algae may be able to thrive in predicted future conditions. Under more acidic conditions in laboratory tests, seagrasses have shown higher growth and reproductive rates. One study found that calcifying algae would occupy about 92% less area under acidic conditions, leaving all that space open for types of thriving non-calcifying algae. While this may seem like an opportunistic balance, an overabundance of non-calcifying algae has the ability to settle on and effectively smother coral reef habitat. But on the bright side, some groups of phytoplankton reproduce at such a rate that it is likely that they may be able to adapt to more acidic conditions at a rate matching the rising acidity. All these effects on marine life and their complex interactions with one another eventually make their way back to our human society. We as a society are heavily dependent on a flourishing and biodiverse ocean. In recent years on the west coast of the United States, near total failures have been witnessed in aquaculture facilities as well as natural habitats for oysters. While it has not been ascertained if human-induced acidification is the cause for these drops in numbers, as other factors still need to be ruled out, the water that these facilities use and that can be found in oyster habitats in that area are unusually low in pH. However, it's been determined by others that ocean acidification is indeed responsible for over $100 million in losses, as well as jeopardized over 3,000 jobs in the Pacific Northwest. These fluctuations and losses serve as an alarming warning to what may come in the future. In 2007, the U.S. commercial fishing harvest revenue totaled nearly $4 billion, and mollusks contributed nearly 20% of that number, almost $750 million. Economically, a sharp decline in shellfish abundance would be disastrous, bearing in mind cascading effects that would occur if one species were to suffer severely. In the near future, jobs for these fisheries may be at stake and food sources could diminish. Outside of commercial fisheries, recreational fishing is also economically important. In 2007, the total economic impact of recreational fishing in the U.S. approached $50 million and supported almost 350,000 jobs. Ocean acidification threatens the socioeconomic status of our coastal communities who build themselves on abundant fisheries. Around the U.S., the risk of social vulnerability to coastal communities, defined as the local importance of shellfish coupled with adaptive potentials of communities, varies from region to region, but much of the U.S. coast is at risk for socioeconomic turmoil. The Gulf Coast communities, Carolina coastal communities, and parts of New England coastal communities are at highest risk for severe impacts from ocean acidification. The implications of failing fisheries are grim for our country, but pose even more of a critical threat to island nations who often use their coastal waters as a primary food source. To make matters worse, marine food webs are tightly interwoven, and even if one species fails to survive the coming changes, it could have cascading effects through the oceans. Plankton, some of the most vulnerable to changes in the ocean, form a foundation for nearly all of the rest of marine life. Small phytoplankton are fed on by larger zooplankton, who then become food for larval fish, who are then consumed by a larger fish and eventually top oceanic predators. Plankton also directly feed larger marine life such as whales, who filter feed on these species en masse. This is just one small snapshot into how planktonic species are pillars for the variety and abundance of life within our oceans, and how critical their survival may be for life as we know it, not only within our oceans, but for ourselves as well. Ocean acidification has emerged over the last 2 decades as one of the largest threats to marine organisms and ecosystems. Currently, there are local, national, and international policies and organizations in place to curb behaviors and actions that accelerate climate change, and specifically ocean acidification, but they are not enough. Many of these policies use non-urgent language such as encourage and have soft goals to hit, with little to no consequence for missing targets or committing infractions. For example, the Kyoto Protocol, which instated modest goals for adopting countries to hit in regard for greenhouse gas emissions, has only made a small dent in emissions despite being one of the most well-known and widely adopted international agreements. It has been found that countries abiding by the Kyoto Protocol have a 7 to 10% reduction in carbon dioxide emissions compared to what they would have had in the absence of a binding agreement. Despite being soft on economy and industry, these weak agreements are helpful, but overall not enough to slow the rate of change to the point where we can avoid a catastrophe. The rates at which we slow our pollutant emissions need to match the severity of the issue at hand. The outcome of large international agreements like the Kyoto Protocol is unsurprising considering the rat race of the global economy. Nobody wants to sacrifice, and everybody wants their opportunity to expand economically, usually with the consequence of increased emissions. It would take a bold leader with a strong backing from their populace to truly sacrifice their country's economy and standard of living for the greater good of the planet. Our society needs international agreements that do more than offer suggestions and merely acknowledge that there is a problem. An effective agreement must have every party admit that this is to be a time of sacrifice in order to avoid global-scale crises for the next generation. Aside from direct governance, there are organizations such as the Environmental Protection Agency and the National Oceanic and Atmospheric Administration in the United States that fund and conduct research as well as provide education and outreach on matters of climate change. Organizations like these and many others that are similar are crucial to changing human behavior on our planet. Governments have pressure to keep the economy growing, whereas for individuals it is much easier to make personal sacrifices in the name of the environment. Becoming educated on issues of climate change with the help of these organizations is a great first step in figuring out what one can do on an individual or household level to mitigate the effects of overconsumptive lifestyles we have enjoyed. Figuring out one's carbon footprint and identifying the most efficient ways to reduce it should be a priority for every household. With the rise of supply and demand of electric vehicles, a trend of individual environmentally based choices can already be seen across the country. The faster these trends grow, the more climate change our society will be able to mitigate. According to the EPA, transportation accounts for about a third of greenhouse gas emissions, with electricity generation just behind it. Theoretically, up to 2/3 of our greenhouse gas emissions could be accounted for if electric vehicles were mandated daily drivers and their power was sourced through renewable methods. In order to power our society into the future, our energy is going to need to come from renewable sources such as solar, wind, and hydropower. These methods of harnessing energy are largely promising on a national and global scale, but require much more investment. Opposition from fossil fuel industry is present and distracting from national initiatives to make renewable energy commonplace. Much like electric vehicles, observations of personal use in solar panels is on the rise. As investments come in and innovations are fostered within these renewable industries, their costs will reduce, hopefully to a point where they become the obvious choice and power source. Promisingly, renewable industries are on the rise, but do require more demand and support from society. Ocean acidification has emerged over the last 2 decades as one of the largest threats to marine organisms and ecosystems, and it is clear that the rate of acidification is threatening many marine species and ecosystems. Calcifying organisms such as coral reefs, shellfish, and plankton are among the first potential victims. Ocean acidification will also impact various economic sectors such as fisheries, tourism, and coastal communities, and may have severe indirect effects on much of the global economy and population. As important as international treaties are in working unitedly to mitigate these effects of climate change, personal behavior and attitude is just as important, if not more so. In theory, governance should follow the people's will, and if individuals adopt environmentalist attitudes, naturally they would choose their governance to reflect that. I'd like to leave you with a quote from Dr. Julia Ekstrom. Ocean acidification is a global, long-term problem whose ultimate solution requires carbon dioxide reduction at a scope and scale that will take decades to accomplish successfully. Thank you.